This video is about the chemical fuels that our body uses to produce ATP. In the key knowledge, we need to both know chemical and food fuels. However, for this video, we're going to focus specifically on chemical fuels and how it is related to the intensity, duration, and type of activity we're doing. Here is an overview of both chemical and food fuels. This video is just focusing on the chemical fuels. ATP, stored in the muscle, and CP or PC, also stored in the muscle. These are chemical compounds that our body breaks using the anaerobic energy systems. So, let's look at what system uses these chemical fuels. The relevant system that uses ATP and CP to create energy are the ATP-CP system. This is the system that breaks ATP that is stored in our muscle to produce energy. However, we only have about 2 seconds of stored ATP in our system. Therefore, the chemical fuel that this energy system uses, the ATP-CP system, is PC or CP. It's phosphocreatine or creatine phosphate. So how does it do that? How energy is released from ATP is when adenosine triphosphate, that's 3 phosphates, ATP, when that is broken and one of the phosphates is broken off, that's when we get our energy. This then breaks off into what's called ADP, adenosine diphosphate, and we're also left over with an inorganic phosphate. So when this process occurs, this chemical reaction takes place in our muscles, that's when we produce energy. However, there is only enough ATP stored in our muscle of only about 1 or 2 seconds, only for enough movements to do a jump. So then our body uses stored PC in our bodies, and this is also limited. We only have around 10 to 15 seconds worth of PC stored in our muscles. We use this chemical fuel and it's broken down into a phosphate and a creatine, and then that phosphate then joins up with the ADP, the adenosine diphosphate, to reform more ATP. So that gives us now some more ATP that we can then break for energy release. So recapping, the 2 chemical fuels that we have stored in our bodies are ATP, which is adenosine triphosphate, as well as our PC or CP, phosphocreatine. They are in limited supply, and hence the reason why we need to derive ATP from other energy sources. So the energy system that uses these chemical fuels is the ATP-CP system. Here is an overview of all 3 energy systems that are used to create energy for movement. The chemical fuels that we're looking at are just the anaerobic energy systems. So the one that we're specifically looking at that uses the chemical fuels, ATP and PC, is the ATP-PC system. And we use that by breaking off the PC so that the extra phosphate can join the ADP to produce more ATP for energy. This table shows the 3 energy systems, ATP-PC, anaerobic glycolysis, and the aerobic energy system. We are specifically looking at the ATP-CP system because that's a system that utilises the chemical fuel creatine phosphate or phosphate creatine that we break to join up with the ADP to produce more ATP. What's interesting about this chemical fuel is that we don't need any oxygen, so it's an anaerobic energy system, and it gives us approximately 0.7 to 1 ATP. 0.7 to 1 ATP. So it only gives us a very small amount of ATP, say compared with carbohydrates. It gives us about 36 ATP in the aerobic system. This only gives us a small amount of ATP, but it's so fast, and that is the benefit of using this system, because it gives us energy very, very quickly. Also, the duration of using this energy system and this fuel, PC, is only about 15 seconds. So it's very, very short. So now looking at the capacity of the chemical, how much of it do we have? So as you can see from the table, again, we are just looking at ATP and PC. If we're running at about 75% of max, so that's a an easy jog, we will have enough ATP PC that will provide ATP for about 30 seconds worth. Now, if we increase the intensity, the time that our stored ATP and PC in our muscle will give us will be reduced. So as intensity increases, the amount of time that we can that fuel provides us with energy will be smaller. This is one of my favourite diagrams. This helps us to understand two things. It helps us to understand the rate. So what is the rate? So the rate, okay, which is this column here, the rate, that's how quickly the energy is produced. And the other great thing about this table is it shows us what's called the yield, or another word for yield is capacity. It's the total amount of ATP or energy that the energy system and the fuel will provide us. So we're looking at just the PC used by the ATP-CP system, and as you can see, the rate, how quickly, it's the fastest. It's the fastest producer of ATP. However, it only gives us a very small amount of ATP. Look, it only gives us one mole of ATP. So, so this is very important. So why is this important? Well, our energy systems provide us with different rates of energy and uses different fuels. Now, depending upon the exercise intensity, the duration, availability of oxygen, all these little things here, and fuel availability, that will determine which of the three energy systems are dominant. Remember, they are all activated together. They all work sequentially, but in an overlapping way. However, one of them will always be dominant, and one of them is dominant based on how much fuel we've got. If we've been exercising at 100% maximum for 60 seconds, we won't have any ATP or PC stored in our muscles left. Therefore, we use a different energy system to provide us with the ATP. This graph helps us understand how PC is restored. At the beginning of exercise, we have lots of PC. We've got 100% capacity stored in our muscles. However, as we know, this only lasts for about 10 to 15 seconds, depending upon intensity. And after it has reached 0%, after we've used all our PC, it then takes, as you can see, that's 1 minute, that's another 2 minutes, that's 3 minutes, this is another 5 minutes. If we go up there, this is almost back to 100%. So this time here it takes us about 5 minutes to restore our PC back to its original levels. Okay, now if we start exercising again at the 2 minute mark, we will only have about 80% of our PC in our muscles ready to go. Therefore, we are not going to last using the ATP-CP system, that fast energy system, for as long. Whereas if we wait the full 5 minutes and our PC levels are back to nearly 100%, then we can utilise that fast energy system for the same length of time, about the 10 to 15 seconds. So this is where the type of activity we do is very important. If there are times available for the body to restore that PC, we can use that system to its maximal capacity, which means that we're not relying on the anaerobic glycolysis system, which, as you can see from this graph, has a slower rate of energy production. It's still pretty fast, but not as fast as this one. Here is another table that shows us how quickly our PC can be restored. So this is recovery time. As you can see, it takes at least 1.5 minutes to get close to being 100% restored, and it takes 10 minutes of passive rest, so that's no exercise, to get all our muscle PC stores fully restored, ready to use that system at its full capacity again. Please be reminded that we still use that system, say we only get 2 minutes of recovery, so we get 120 seconds recovery, we'll almost be fully restored. But that, because it's not 100%, it means that we'll be relying on the anaerobic glycolysis system, the slightly slower system, a little bit earlier. So our performance, in theory, will be slightly lower. So this table just helps remind us of the 3 energy systems, ATP, CP, and which fuel it uses. So our ATP, CP system uses phosphocreatine as well as our stored ATP, that's our other chemical fuel, to utilise energy for high intensity and short durations. So the fuel that are chemical are ATP and PC, and this is used by our ATP, should be CP system. And finally, here is a summary of some notes about our chemical fuels. The main ideas are that the stores are limited. We have a very small and short supply of our chemical fuels stored in our bodies, in our muscles. However, they provide us with ATP very quickly and very explosively. And to restore our PC, we need to have a passive recovery, which is just a still recovery, and it takes at least a couple of minutes to get up to the 95 to 100% percentage rates back in our muscles, so that we can utilise that system to its maximum. and we only have enough PC stored in our muscles for about 10 to 15 seconds of high intensity activity, and ATP we only have a couple of seconds.